In this video, I have discussed everything related to mole concept, like what is the meaning of mole, what is the meaning of atomic mass unit, and where are we going to apply the mole concept, how to calculate number of moles, number of particles, volume, everything on mole concept. So let's begin with. So what exactly is the meaning of a mole? See, 1 dozen. 1 dozen means what? 12 objects. 1 gross means 144 objects. So in the same way, 1 mole, this is about atomic level. So 1 mole is the same as 6.023 into 10 to the power 23 objects. So this is the whole story of it. Like earlier when we were doing statement problems, 1 dozen means we used to take 12. So next onwards, when we talk about 1 mole of any object or any substance, we will know that 1 mole has not 12 objects, not 144. It has got 6.023 into 10 to the power 23 objects. And this number 6.023 into 10 to the power 23 is called the Avogadro number, named after the scientist Avogadro. Now let's move on to understand more about it, the mole concept. So before starting the mole concept, we should know about the meaning of atom, element, molecule. So element are those that you see on the periodic table, and those elements are basically atoms. So an atom of an element. Okay. Atom is the smallest particle of matter that participates in a chemical reaction. And now if I want to know atom's weight, atomic's weight, like any atom's weight or subatomic particles like electrons, protons, neutrons weight, if I want to know their weight, I am not going to use a beam balance or spring balance to know its weight in terms of grams and kilograms. So it's not about the device, of course. Atom's weight or subatomic particles weight is measured in terms of atomic mass unit, that is AMU. So 1 AMU, sometimes it is taken as a 1 unit, same as a 1 Dalton, same as Dalton, DALTON, same as 1 Aston, same as 1 Avogram. So these all mean the same. And what is 1 atomic mass unit? It is the smallest unit to measure mass of an atom, any atom, or subatomic particles. And what are subatomic particles? They are the electrons, protons, neutrons, or those elementary particles which come out of nucleus of an atom during a nuclear reaction. Moving ahead, what is 1 atomic mass unit? That was the definition, but the value. 1 atomic mass unit is actually 1/12 of mass of 1 carbon-12 atom. Carbon has 3 isotopes, carbon-12-6, carbon-13-6, carbon-14-6. It is about carbon-12-6. Carbon-14-6 is used for carbon dating to know age of fossils. But this is about carbon-14. What is mass? 1 atom. What is mass of 1 atom of carbon-12? Mass of 1 atom of carbon-12 is a 12 divided by Avogadro number. This ratio in terms of grams. So here most of the time we will have a confusion that this mass came in terms of grams or AMU. Okay, any 1 atom mass is actually that isotope's number, mass number 12 divided by Avogadro number. When you do, you get your answer in terms of grams. Now what is 1 atomic mass unit? 1 atomic mass unit is a 1/12 of 12 divided by Avogadro number. This on solving, you get it as 1.6605 into 10 to the power minus 27 kilogram or 10 to the power negative 24 grams. So this is the conversion of atomic mass unit and kilograms or grams. That's the connection. Moving ahead, mass of hydrogen atom. That is 1.008 AMU. Now see, until now we were doing in terms of grams. Now it came as atomic mass unit. How do you know when your answer comes in terms of atomic mass unit and when it comes in terms of grams? Grams, when you calculate as atom's mass, like oxygen, 1 oxygen atom mass is a 16 divided by Avogadro number. That mass is in terms of grams. Atomic mass unit, you will know Like in 7th point, you see mass of chlorine. Chlorine in a sample has 75% of chlorine 35 isotope and 25% of chlorine 37 isotope. So what is atomic mass? Means a relative atomic mass. Atomic mass or relative atomic mass is always in terms of AMU. Gram atomic mass is in terms of grams. That's the difference. Okay. So atomic mass of chlorine is what? 75% of 35 plus 25% of 37, because it is percent. You are dividing by 100. On solving, you get it as a 35.5. So atomic mass of chlorine is 35.5 AMU, atomic mass unit. Likewise, what is atomic mass? Relative atomic mass of carbon. So carbon has 3 isotopes. Carbon 12 is 98.89. Carbon 13 is 1.108. Carbon 14 is a 2 times 10 to the power negative 10. So you can calculate atomic mass of carbon as 12 times 98.89 plus 13 times 1.108 plus 14 times 2 into 10 to the power negative 10. So individually you have to solve this, all the brackets, and then add them, divide by 100. When you do so, you get 12.011. Atomic mass of carbon is a 12.011 atomic mass unit, because atomic mass will be in atomic mass unit. Okay. Here 9th point, 1 Avogadro number. What is not 1 Avogadro number? Is 6.023 in 10 to the power 23. This number you remember. This is of great use in this chapter. How many types of masses we are knowing? Atomic mass means the relative atomic mass always measured in terms of atomic mass unit. Gram atomic mass is in terms of grams. Molecular weight, that molecules, oxygen molecules weight is 2 times 16, 32 grams. 32, that's grams. Okay. Gram formula mass, like calcium carbonate, calcium 40, carbon 12, oxygen carbonate CO3, 3 times 16. So when you calculate, you get your answer in terms of gram. Molecular mass means molar mass. Now coming to the topic of mole. What is a mole? It is a unit used to measure, it is a unit used to express the quantity of matter. Quantity of matter. So 1 mole particles, its meaning is 6.023 into 10 to the power 23 entities. That means 1 mole of carbon 12. 1 mole of carbon 12 has 6.023 into 10 to the power 23 atoms. 1 mole of any object has 6.023 in 10 to the power 23 atoms, molecules, ions, electrons, protons, neutrons, etc. So entities meaning is that. So 1 mole is related to Avogadro number. Very similar to, as I said earlier, 1 dozen. 1 dozen is same as a 12 entities, means 12 objects. Like that, 1 mole means 6.023 in 10 to the power 23 objects. Like that. So this chapter, this topic that I'm discussing right now is about mole concept. So everything on moles. So number of moles calculation will come a good number of times. We can calculate number of moles using 3 different formulas. I have listed all of those. The first one, number of moles is given mass by molar mass. Number of moles is number of particles of substance by Avogadro number. Third one, number of moles is given volume by standard temperature pressure, volume of that object at STP or NTP. So these 3 together I am combining and creating one formula. Just see, this formula is of great use for answering any numerical problem on mole. Number of moles is given mass by molar mass. Same as number of particles. Number of particles means what? In the question they'll say number of atoms, number of molecules, number of ions. Calculate they say. So that is it. By Avogadro number is same as a given volume by STP volume, that is 22.4 liters. 22.4 liters. You just remember this one relation. This one relation is enough to answer everything on mole concept. Let's move on. Yeah, so here in note I wrote 2 points, 3 points in fact. Mass of one single carbon atom is 12 daltons, means what? 12 AMU. 1 atomic mass unit is 1/12 of carbon 12 atom, means what, 1 by 12 times 12 by Avogadro number. So 12 cancels, so 1 by Avogadro number. That is why 1 atomic mass unit or 1 Dalton is the reciprocal of Avogadro number. So yeah, the first point here I wanted to say, I just want to clear it. Mass of single carbon atom, right? So 1 atom of carbon is 12. That is the mass number, carbon 12-6 mass number by Avogadro number, 6.023 in 10 to the power 23. Similarly, if you want to know what is the mass of 1 atom of oxygen. Okay, so what is the mass number? 16 divided by Avogadro number. Okay, now this one comes in grams, kilograms. What do you think? This one is in terms of grams. This one is in terms of grams. Okay. Moving ahead, 1 Dalton is 1 atomic mass unit, which is same as 1.6605. Here it is rounded up into 10 to the power minus 27 kilograms or negative 24 grams. Moving ahead, 1 G atom is same as 1 mole. So sometimes the question, they don't ask us calculate number of moles. So they say calculate number of G atoms, which is same as Avogadro number, which is same as G atomic weight. Now let's begin with the application questions. How many G atom means how many moles? We have to find number of moles. And number of atoms means what? Number of particles are present in 60 grams. This is the given mass of carbon. What is carbon? Carbon means you have to take molar mass of carbon. That is 12 grams. That's the information. Let's begin. Number of moles. Number of moles is given mass by molar mass, 60 by 12, that is 5 moles. Second one, number of particles. So we will write the next part of formula, number of moles is number of particles, means what? A number of number of atoms. Okay, number of particles, here they ask number of atoms. So number of atoms divided by Avogadro number. Number of moles, just now we found 5. Avogadro number is 6.023 into 10 to the power 23. You have to just do a simple cross multiplication to know the number of atoms that is present in 60 grams of carbon. Number of atoms present in 60 grams of carbon is 6.023 into 10 to the power 23 times 5. You do that, approximately you get this as 30. Into 10 to the power 23 atoms. That means 60 grams of carbon has a 3 beside 24 zeros. That many atoms. Oh wow, very big. So big. Second application question, calculate the number of G atoms, means calculate the number of moles. Number of moles. And mass of the element which has got this many atoms. So number of particles is given. Number of particles is given, whose mass we have to find. Element which has got this many particles, 2 into 10 to the power 23 atoms in it, will have how many? Oh wow. What is the mass of 2 into 10 to the power 23 atoms of an object which has atomic mass of 32? 32 is the molar mass. So we are using that common formula, that connecting formula I wrote. Number of moles is a given mass by molar mass, that is number of particles by Avogadro number. Number of particles in the question is 2 into 10 to the power 23. Avogadro number is 6.023 into 10 to the power 23. Most of the times we are not rounding, we are not taking the nearest number of 6.023. Maximum take the number as 6.023. At times, just we have to round up. Okay. Number of moles, okay, molar mass is given 32. So we have to find mass. You see, you can use this part of the formula to find the mass of 2 into 10 to the power 23 atoms of that object whose molar mass is 32. So first we should find number of moles. That's why I'm using the first part of the formula and the last part of the formula. So 10 to the power 23 cancels and you have 2 by 6.023. So I take it as a 2 by 6, that is 1/3. So number of moles is 1/3, means what? 0.33 moles. That's the first part of the answer. Second part, the answer is mass. So you just do a simple cross multiplication. That was 2 by 6 approximately times 32. So you can do is a 1/3 of 32. 1/3 of 32 is 10.2, approximately this many grams. Remember grams. Okay, always don't fall into the AMU. So that's very clearly grams. How many? Next question. How many moles? We'll find that. Number of molecules of oxygen means number of particles are there in 64 grams, which is mass, given mass. And then we have to calculate mass of one molecule of oxygen. So let me answer the last one first. What is the mass of one molecule? One molecule of oxygen. Mass of one molecule of oxygen is one molecule's mass. That is a 2 times 16 divided by Avogadro number. So this you solve it, your answer comes in terms of grams. So no confusion here. It comes in terms of grams. Then we have to calculate number of moles. Number of moles is given mass 64 by molar mass. Oxygen's molar mass is at 2 times 16, that is 32. 64 by 32 means at 2 moles. That's the first part of the question. Second part of the question is the number of particles. So you know that number of moles is the number of particles, means what? Number of molecules of oxygen. Number of molecules of oxygen by Avogadro number. You have to just do a simple cross multiplication to know the number of molecules of oxygen present in 64 grams. That is a 2 into 6.023 into 10 to the power 23 molecules are there in 64 grams of oxygen. That is a 12.043 into 10 to the power 23 molecules. Okay, moving ahead to some concept clarification, MCQs. One atomic mass unit is same as, see this one, 1.66 into 10 to the power negative 24 grams. Second one, mass of one atom of element is divided by 1/12 mass of carbon 12. That is actually relative atomic weight. That is how you calculate the relative. Relative means something over something, relative to. Which of the following name is not related to atomic mass unit? See, Dalton and atomic mass unit are same. Pascal is for pressure. Avogadro, it's actually avogram. It is actually avogram. And avogram and AMU are same. Astron and AMU are also same. Third one is done. Fourth one, atomic mass. Atomic mass means atomic level mass. Atom's mass is measured in terms of AMU. One of hydrogen. Of hydrogen is 1.008 AMU. Fifth question, 1 mole of sodium represents. Mole of sodium. Sodium is not a molecule. 1 mole of sodium will have Avogadro number of 6.023 in 10 to the power 23 atoms of sodium. Moving ahead, sixth question. Number of oxygen atoms. They are asking us to calculate number of particles. Present in 50 grams. This is the given mass. In calcium carbonate, this we'll use to calculate the molar mass. Let's do it. Number of moles is given mass by molar mass by number of particles by Avogadro number. This is the formula that we are going to use. Given mass is 50. Molar mass of calcium carbonate. Calcium is 40 plus carbon is 12. CaCO3. So 3 times 16. So the denominator is 100. Other side you have number of oxygen atoms. Number of oxygen atoms divided by Avogadro number. You have to just do a simple cross multiplication and you know that 50 by 100 is 1 by 2. So half of Na. Your answer is half of 6.023 in 10 to the power 23. So that is more apt for the B object, B bit. That is 3.01 into 10 to the power 23 atoms. So answer is B option. The decimal was wrongly typed. Seventh question, molar volume of any gas at standard temperature pressure. That is 22.4 liters. Next question, number of nitrogen molecules. So we should find number of particles present in 1 cc given volume. That is 1 ml. That is 10 to the power minus 3 liters. Present in nitrogen gas. Okay, nitrogen. You can use this for molar mass. That is a 2 times 14. That is 28 grams. Okay, let's see. We have to find number of particles. Okay, given mass by molar mass given volume by 22.4 liters. So that is 10 to the power negative 3. You have to find number of particles. Oh, we are not using this part of formula. We are using this part. Number of particles by Avogadro number. So you're not using this one. So number of particles we should find. So Avogadro number, you know this. So you just have to do a simple cross multiplication. Number of particles is 6.023 into 10 to the power 23 into 10 to the power negative 3 divided by 22.4. So 10 to the power 23 times 10 to the power negative 3 is 10 to the power 20, and this fraction when you divide, you will get the B option. The B option is the answer. You can calculate and verify. Moving ahead, 9th question. A mixture of 7 grams of nitrogen, 8 grams of oxygen occupies what volume? So we are using the formula given mass by molar mass is a given volume by 22.4 liters. Given mass for nitrogen is 7. Molar mass of N2 is a 2 times 14, that is 28. And you do a cross multiplication. So volume of 7 grams of nitrogen gas is 1/4 of 22.4, that is 5.6 liters. Similarly, 8 grams of oxygen by molar mass of oxygen, that is 2 times 16, that is 32, is given volume by 22.4, 8 ones, 8 fours, 32. So this is also the same volume of 8 grams of oxygen gas is 1/4 of 22.4, that is also 5.6 liters. Now they're asking together the mixture will occupy what volume? So the mixture will occupy a volume of 5.6 plus 5.6, that is 11.2 liters. So you just multiply 1000, you get 11200 milliliters. So your option should be the last option, and here in this option I see that is 0. 11200 milliliters. Moving ahead to the 10th question. 23 grams of NO2, nitrogen dioxide, has the same number of molecules as which of these? So let's first find the number of molecules for 23 grams of nitrogen. Number of molecules means what? Number of particles by Avogadro number is a given mass, that is 23 by molecular mass or molar mass of NO2. N is 14, oxygen 2. So 2 times 16. 32 plus 14. 14 plus 32, that is 46. So this part is a half. So 23 grams of NO2 has a half of Avogadro number, this many number of molecules. 8 grams of nitrogen has then following the same formula. Number of particles will be 8 divided by, I just consider this as oxygen atom because it's written oxygen, 16 times Avogadro number. This is also half of Na. Next one, number of particles is 28 by carbon atom, say 12 times Na, that is a double Na. Not double, that is close to double. Okay. Next, 16 grams. So number of particles is 16 by molar mass. Sulfur is 32 plus 2 times 16. 32 plus 32, 64. Okay, 1/4. So this is a 1/4 of Avogadro number, and finally 22 grams of carbon dioxide has how many molecules of carbon dioxide in it? That is 22 divided by molar mass, that is a 12 plus 2 times 16. 32 plus 12, 44 times Avogadro number. This is a half Na. Right. So 23 grams of NO2 and 22 grams of carbon dioxide has the same number of molecules in them. Moving ahead, 44 grams of CO2 has how many moles of oxygen? Very simple. It's 2 O2, no? So 2 moles of oxygen. 2 moles of oxygen. You can calculate, then also you get the same. 12th question. Largest number of molecules. Largest number of molecules is in what? Let's calculate number of molecules in all of them. Number of molecules means number of particles in the first one is 28 divided by 12 plus 16 times the Avogadro number. We are using the formula number of particles by an Avogadro number is given mass by molar mass, and we are doing the cross multiplication and to know NP. Okay, so that is 28. So this is equal to Na. This one is also equal to Avogadro number. This one is 36 over 2 plus 16, 18. Oh, it's a double Na. Wow. And the last one, 54 by 2 times 14, that is 28 plus 5 times 80, that's 108. This is a half of Na. So which has got largest? Largest number of molecules is of 36 grams of water, H2O. Calculate mass of 5 gram of atoms of iron. 5 gram. One atom's mass is 56 grams. 5 atoms mass is 56 times. Oh, this may be a, okay, 5 times this, that is 280 grams. Avogadro number is equal to the number of atoms present in 0.012 kilogram of carbon-12. How many moles are there in 52 grams? Very simple. Number of moles is a given mass by molar mass. Helium's molar mass is 4, so it is 13 moles. Calculate molar mass of calcium carbonate. Calcium is 40, carbon is 12, oxygen is 16, but you multiply 3. That turns out to be 48 plus 40, that is 88 plus 2, 90 plus 10, 100. 100 is the molar mass. It is in grams. Okay. What is mass of 1 mole of nitrogen atom? Okay. We are using the formula number of moles is the given mass by molar mass, and you are finding mass. Mass is a number of moles into the molar mass. It's nitrogen atoms of 14, so 14 grams. Okay. Mass of aluminium is 4 times aluminium mass. I don't remember right now aluminium mass, but whatever is, just look into the periodic table and that is the grams. And this one is 10 times. Let's calculate molar mass. 2 times sodium, 46, plus sulfur, 32, plus 4 times 16. Just calculate this. Your answer comes in terms of grams. Okay. Moving ahead for 18th question. Convert mole to 12 grams of oxygen. Convert to mole. Oh, so we should note the number of moles. Number of moles is given mass by oxygen gas. So 32. That is 4 3s, 4 8s. That is 0.375. 20 grams. How many moles? Number of moles is 20 by 2 plus 16, that is 18. 10 upon 9, that is 9 ones, 1 by 9. 1.11 number of moles. In this case, number of moles is 22 over 12 plus 32. That is 44. Oh, this is a 1 by 2. 0.5 moles. 22 gram is 0.5 moles. Okay. What is mass of 0.2 mole of oxygen atom? Mass is the number of moles times molar mass. So here 0.2 times oxygen atom. So 16. So that is 3.2. 3.2 grams. Here mass is 0.5 into water, means what? 2 times 1 plus H2O. O is single. So 18. Okay. So 18.5. So 50 plus 40, 90. So 9 grams. Okay. Next, 20th question. Calculate number of molecules of S8 present in 16 grams of sulfur? Wonderful question. Number of particles by Avogadro number is given mass by molar mass. Number of particles means number of molecules is what we are supposed to find. Avogadro number, you know, 6.023 into 10 to the power 23. Given mass 16, molar mass 8 times 32, that is 256. 16 by 256 is a 1 by 16. So number of molecules of S8 present in 16 grams of sulfur is 6.023 into 10 to the power 23 over 16. So you have to calculate this and you get your answer in terms of this many molecules are present. 21st question, which of the following has highest mass? Let's calculate mass. 1 gram atom of iron, 56 grams. 5 mole of nitrogen, 5 times nitrogen gas, 2 times 14, 28. So 100 plus 40, 140 grams. 10 to the power 24 carbon atoms. Mass and number of atoms. So mass is 10 to the power 24 by 6.023 into 10 to the power 23 times carbon atoms molar mass, that is 12. So 23 and this cancels, you get 10. 120 by 6.023, this many grams. And 44.8 liters of helium's mass. Mass is 44.8. This is the given mass by 22.4 liters times helium means 4. So that's 2 times 4, that's 8 grams. Okay, and about which is the highest? Highest appears to be 5 moles of nitrogen, but before that, what is 120 divided by 6.023? Okay, this one is close to 20 grams. So which has the highest? Highest is 5 mole of nitrogen gas has the highest mass. Moving ahead for 22nd question. 6 into 10 to the power 24 atoms of element weighs this much given mass. In their form of homo diatomic gas. Okay, oxygen, nitrogen, those all. Calculate molar mass of the gas. See, 2 atoms has 2 atoms is 1 molecule of that diatomic gas. So 1 atom is half molecule. Alright, so this will remember. Let's use the formula here. Calculate molar mass, so you use given mass by molar mass is number of particles by Avogadro number. Given mass is 200 grams. Number of particles will be half of, because a diatomic, so single atoms we should say. So half of 6 into 10 to the power 24. You know that Avogadro number 6.023 into 10 to the power 23. Your answer comes in terms of grams. You have to solve it and you get your answer. Okay, that is 3. Okay, so 200 by molar mass is 3 upon 6.023 into 10 to the power 10. That's all. You can cancel this. Okay, so you just do a simple cross multiplication and you get your answer. Molar mass as 40. Molar mass. Molar mass is always come in terms of grams, that you remember. Oh, I got 40. Oh, 40 option is there. 40 option, the first one. Okay. Moving ahead to 23rd question. Calculate mass of oxygen needed for complete combustion of 2.8 kilograms of ethylene. Ethylene is C2H4. Let me do the balancing of this. C2H4. C2, right? 2. Okay. Oxygen. Oxygen 4, 5. Okay. 6. So here make it 3. Now it is well balanced. See, for 1 mole of ethylene, you need 3 moles of oxygen. Okay. So, okay, 1 mole of ethylene. That means 2 into 12 plus 4 times 1. That is what? 24 plus 4. So, 28 grams need 3 times 2 times 16. This much amount, this many grams of oxygen. That is 16 times 6, 60 plus 36, 96 grams. Okay. Okay, so things are in terms of kilograms, so I'm also calculating in terms of kilograms. Okay, so 28 grams need 98 grams. 28 grams of C2H4 need 98, not grams, kilograms. 96 kilograms of oxygen. Then 2.8 kilograms of ethylene need how many kilograms of oxygen? Very simple, do a simple cross multiplication. So it needs a 96 times 2.8 over 28. This on solving, you get 96 by 10, that is a 9.6 kilograms of oxygen. Okay, so I don't see the option, but that should be the answer. 24th question, I just read this case study question. Okay, that's the information about, okay, fine. Let's move on to this. Volume of this many atoms of hydrogen gas at normal temperature pressure is what? Okay, very simple. Volume, right? Given volume by 22.4 is the number of atoms 3.011 into 10 to the power 23 number of particles by Avogadro number. Okay, so this is actually 1 upon 2. So volume is the half of 22.4. Okay, 11.2 liters means 11200 milliliters. 11. This one, the first one. 11.2 it should be. Okay, fine. Second one, mass of one atom of element is 66.64. Okay, molecular weight of X2 we should find. See, molecular weight. So, given mass by molar mass, that is a requirement by number of particles by Avogadro number. We are going to use this. Given mass is 6.64 into 10 to the power negative 23 grams. Molar mass is our requirement number of particles. It is only one atom. And Avogadro number 6.023 into 10 to the power 23. You have to just do a simple cross multiplication to get the molar mass. Molar mass 10 to the power 23 and negative 23 will turn 0. So you have 6.64 into 6.023 grams. You have to solve it. On calculating, you get approximately 39.9. You take it as 40 grams. So answer is the third option. The last part of the question. In a reaction, 1 kilogram of, this is a given mass oxygen gas produced. Okay, fine. How many gram atoms? How many gram atom is G atoms? G atom is what? Moles of oxygen is present in 1 kilogram of oxygen. So very simple. You are using the formula number of moles is given mass by molar mass. You have to find number of moles, G atoms. Mass is 1 kilogram. Molar mass of oxygen is 32. 1 by 32 is actually 0.03125. This number I really did not do the calculation. Very recently I met a very small child, almost a kindergarten age child, who told me the value of 1 by 32. 1 by 32 is 0.03125. Once I said and I just remember. So this many kilograms. Kilograms means what? You just shift the decimal 3 places, right? You get 31.25 grams. So the first option. That is the answer. And so I covered all the questions on all the kinds of questions on mole concept. Now I really want to tell you this, understanding mole concept, kind of summary I created here. 1 mole of oxygen weighs, I'm just putting arrow, just say weighs 32 grams. Okay, grams. Just see, 1 mole of oxygen weighs 32 grams, which is same as 6.023 in 23 oxygen molecules. That is the same as 2 times 6.023 in 10 to the power 23 times 10 to the power 23 oxygen atoms, which is the same as 2 into 8 into 6.023 in 10 to the power 23 number of protons, which is same as same number of neutrons and same number of electrons. So this is all about mole concept and the complete applications of mole. So I hope this video has been very useful to you. Thank you.